Welcome everyone. How are you doing? Good. Okay. All right. Wonderful. Well, my name is Aaron Mazzeo, and I am in the Department of Mechanical and Aerospace Engineering, and I am thrilled to have the opportunity to teach and work with you all this semester. We can be honest and friends. What are you guys thinking about this class? What have you heard? Hard? Nothing? Huh?
Barely passing.
People barely passing. Okay. All right. Good. What else?
Very tough exam.
Very tough exams. Okay. All right. Yeah. Fair. That I think is related to your comment as well, right? Okay. We are going to get to work together to try to make it so it's not unbearable. Okay. We will. And we're going to do some things. It's going to be demanding. This class is demanding. Okay. We're going to do some things that I hope, though, will ingrain some of the principles, and I hope that we can work together, okay, as we do this. Today, we're going to start off discussing some of the way this class is structured, okay, and some of the things that we're going to do, some of the things that might be a little bit different that we've done in the past as well. And then we're going to get into allowing everyone to work on solving problems. And that process is hopefully collective and potentially something that enables you to get to know other people in the class and work together. But if you want to go it alone, I completely understand. All right. What we're hoping to accomplish here, though, is having these sessions together be very much episodes of active learning. Okay, so you're going to be able to complete most of the homework here in the classroom, I hope. Okay, and okay, I think we're back. Okay, so it should be everything what we do in class should be on YouTube. Okay, you guys, of course, your privacy is preserved. All right, but it should all be on YouTube for you to go back and look at and afterward as well. Okay, we are going to have a teaching assistant. Praj, are you here? Should be here. He was going to be here. I don't see him. Okay. But he'll be here as well as we go around and we answer questions that you might have on the homeworks. All right. And his office hours will be in the engineering building as well. Of course, we have a Canvas website. Okay. And we have another website, all right, on engineering-content.com, all right, and then there's a YouTube channel as well. There's a GroupMe, which, as long as we're respectful, should be a nice resource for people. The homeworks are meant to be done together, okay? Everyone, of course, submits their own answers to the questions. And as you'll see, the numbers are typically different for everybody. Here's our esteemed TA.
Hi.
Okay, this is Praj. Okay? Yes, Praj. Okay. We'll get an opportunity to do some simulation as well. Okay? And we'll use FreeCAD and we'll use Pre-Pro Max for those simulations. And then, how many of you have done anything with Python before? A little bit, okay, all right. So you'll also have a chance to use Python if you choose. It's not mandatory, although there are a few assignments, a few questions that essentially we've given you the template, and all you have to do is run the scripts to answer the problems, okay, in Python using Colab. Has anyone used Colab before? Yeah, okay, right. So it's in the web browser. FreeCAD is not in a web browser, okay, but it's actually one session during the semester. Your team of 3 will go to D123K, which is in the the old engineering building, and you'll get to run some tensile tests. You'll get to do some material testing. You'll get to characterize aluminum and steel, for example, okay? It's just to give a hands-on component. And so it's like a one-time thing that you'll get to do with your team, all right? So it won't be too significant, and you should more or less be able to complete that assignment almost entirely during that time, okay? And Shrije will be kind of a lab assistant there, so you'll get to meet him in that place, okay? Attendance. All right, so what we're going to do with attendance is a little bit different, all right? What you should see if you go to Canvas now, all right, is that there is a question that is open until 7 p.m., okay? And in this question, let's see if I can do this correctly. In this question, all you have to do, okay, and I definitely want to preserve people's privacy, okay? All you have to do is take a selfie with you. So you answer the question as affirmative. So everyone, you don't want to get anyone else if possible, all right? Just a selfie with you and this in the background, okay? And that's how we're doing attendance, okay? And that's 5%. So you're welcome to do this now, okay, if you like. So you got it done, all right? Because I won't be flashing it the entire time, all right? Take a selfie with the screen. Yes.
I have the class schedule on. I'm brag, but I'm not.
Okay, that's okay. That's okay. After class, we'll get you out. All right, but go ahead and take the selfie.
Yeah, I still have it.
Okay, with you in it.
Yeah.
Okay. All right. All right. What's that? So if you go, I'll show you now. All right. So give me a second. To everyone, let's just wait. Is everyone done with this part? And in the future, I'll just leave it up for a little while. This will probably be more during the problem-solving portion, but since we're talking about how the class is running today, this is just so you can go ahead and do this, right? So try not to get anybody else in your picture, just you if possible, okay? To keep the privacy of those involved. Okay, can I move this off? All right. Great. Okay. So just make sure that's still going. So in Canvas, what did I just? Oh yes, of course. Okay, so we'll go back to the other screen. Okay. Yes.
I just included the image as a comment because it's not published yet. Is that okay?
It didn't, so this is good, we may have some technical issues to work out then. So what I thought would happen of course, now it's gonna call my phone. Yes? Okay, so this didn't work for you? It's not working. So what should happen is you should see this. You just hit true, okay? And then you upload the JPEG.
How did you get there?
So, okay, so you go to the bottom. So if you click on, you see the modules at the very bottom, there should be this attendance.
I think you gotta publish the
Yeah, I cannot find it.
It's not, oh! Now we should be good. This is why you will see I make mistakes, okay? So it's good to, it's like having a new car and scratching it. You get it out of the way. All right? So, all right, so now you should be able to upload, you should be able to hit the true statement, and you should be able to upload the picture, okay? So attendance is not mandatory, but it is 5%. All right, so it's you know, there are some people who I respect quite a bit that don't really need me. Okay, it's okay. All right. I just wanted to give a little bit of incentive. All right, to come. That way we have a community where we can discuss and talk about the problems that we're working on. All right. Let me flip back. Over here. All right, great. Okay, so we're gonna have 3 exams. All right, 1, 2, and the final. All right, and so those are pretty self-explanatory. Trying to make things kind of evenly weighted. All right, so the class is about doing all the things, and if you see that that we have about 31%, that's not based on the exam. So I hope that will give people an opportunity to demonstrate what we're learning. Okay. Now, so there are some resources that I want to point out here. Okay, we talked about the GroupMe, and you should be able to see that the GroupMe link is on the website right now. Okay, or it's on the Canvas right now. We also have a website that we get to use, and just so you know, right? If the Rutgers policy is, if you publish a book and you use that book for your class, if you make any money off the textbook, all right, you're supposed to give it to charity. That's the Rutgers policy. There are no ads on this website, okay? I'm not making any money on it, okay? 0 at this point, okay? If ads do appear, let me know, all right? But it's a tool. It's a tool that I think allows us to present the material, and it's also motivating for me to essentially bring this material to a larger audience potentially, right? So we're working together to try to make the material better, okay? So as we go through things, right? So here's session 1. As we go through things, if there's a good video that you like, all right, let's put it, tell me, and I'll put it there if it's relevant, right? Who's this? You guys took statics, right? There's no way you don't know who this is. Yeah, right? The bomb, right? For some, okay? Okay, so yeah, he's got wonderful YouTube videos that explain how to do the problems, okay? We have the organic chemistry tutor, all right? Right, another guy, right?
My Calc 1 teacher.
Your okay, right? Okay. So this is not about hiding resources. Okay, this is about putting out the best resources that we can for everybody. Okay. The textbook is very good. Okay, but I only have it down as suggested. Okay, and you took statics, and so you're probably familiar with Hibbler already, right? And many of you are taking dynamics as well. I think that Hibbler is also being used there. Okay, so a great textbook. The problems aren't coming from that textbook, though. Okay, at least the ones that are graded. So you don't have to pay for anything. But if you get a copy of that textbook, go ahead and use it. Okay, I still haven't. It's not that hard, but I need to on the website. I still need to go back and put up the relevant sections. Okay, so like I did it for, I think I did it for equilibrium at the bottom. Okay, yeah, so if you're interested, so this is the printed text. So these are sections of the textbook, of Hibbler's book, that are relevant. So if you want to follow along or read along, you're welcome to do that. If you have Hibbler's textbook, it'll be pretty obvious where we are in the textbook. All right. Any questions so far on what we've discussed? Yes.
Why not 10th edition?
I just haven't seen it. That's why. You can do, yeah, get whatever edition you want. Okay. I have read. I mean, I've used the 9th edition. I have a copy. Actually, I gave Praj a copy of the 11th edition. It's a great textbook. They keep refining it. Things haven't changed that much, though. All right, from these different editions. Okay, good. So whatever copy you want to get is fine. And of course, I fully endorse using legal methods to get whatever resources you're using for this course. Okay, I've tried hard also. Okay, to as you'll see, like you're like, why are the slides like the way they are? Why are there so many handwritten things in the slides? It's because I also don't want to violate copyright, okay, if I can. All right. So what you'll see is the images, they come from the Wikimedia Commons, all right, and so they're open, they're creatively sourced open kind of thing. That's not the right terminology, but you get my point. And it's great that these teachers, all right, are putting their YouTube videos up with shareable embedded links, right? So you can embed this on a website. You can watch it on the website. You can go to YouTube, do whatever you want. Okay. Other comments? Other thoughts on this? Okay. There are also digital resources as well. So again, if you find that you want to suggest more digital resources that you find helpful, that's great. And when we do pressure vessels in particular, you'll need to look at the digital resource, essentially, at least if you want to solve the problem quickly. Okay, so there's a nice couple of pages by David Roylance at MIT solving some statics or solving some mechanics problems. Okay. All right, so that's kind of how the mechanics, okay, of the course will work, right? A lot of the content is on this free website, okay? during class, all right, I will talk for a little bit. Today's the first day, so I'm talking probably, well, those of you who know me, I can talk for a long time, all right, so I'm sorry. I'll try to introduce things, okay? And then bring your headphones, if you like, to start going through the videos. Some students, they're like, I look at your videos and I do the problems, and your videos tell me exactly how to do the problems. Other students are like, nah, I'm gonna do Jeff Hansen. Fine, do whatever you want, okay? You'll get the material either way, especially as you solve the problems on Canvas. All right, so how do the Canvas modules work? There's a module which is equivalent to the session, right? And as you see here, there are 25 sessions. Okay. That's the number of times I think we're going to meet without the exams, okay, without the 3 exams. Right now, if I did it correctly, we can double check. You should be able to see all the modules. Can you see all the modules and all the problems on Canvas? Okay, so those I released properly. What we'll do, if people like say, no, we need more time or something, or there's something that comes up, right, we can be flexible. But right now, the way it works is the assignments are due by the end of the next session, right? So session 1 is open, as is session 25, if you want to do it, right? You can do it. It's due, though, by Thursday at 7 p.m. Okay. What we found, we experimented a little bit with this, all right? And in the end, I was like, well, I really want people not to be distracted by the previous session when they're in the next session. But what I found, and you can disprove it, is that it actually is kind of nice, because people have been working on the session during this class, and then they have some time by themselves. Okay, we have some time by ourselves, and then like if there's just 1 or 2 problems that they still need to get done, we can get them done in that session. All right, so if like you're hung up on one problem, okay, we should be able to like get you through it by the end of the next time, right? And then you'll have some time to process it. Okay. And that's pretty much it. The thing that's kind of up in the air right now is the lab, and that's on our end. We're trying to get that ready for you, so you have a more hands-on experience. Any other questions? Okay. Yes.
It's just the OCD. Why is it 22, 23, and 24 instead of just multiple 3?
What do you mean?
For the exam percentages.
Oh, do you want to change it? I just felt that you should be rewarded slightly more. Maybe it's, I don't know, just slightly more as the material gets harder. Exam 1 will, okay, so there's this little story. When a few years ago, I was talking to a professor, and how do you make your exams, right? And so this is probably too much information. It's like, first exam, really hard, okay? And then, oh, that's so hard. And then you pretend to be the merciful person by making the second exam really easy, right? And at the same time, it's like, hey, you guys are doing so well, you've learned so much, you've improved so much. And then you hit them hard on the third exam, all right? We're not going to try to do that, okay? Nonetheless, you will see, if you think the material that is covered in exam 1 is hard, wait till exam 3, okay? Not because of me, okay? Not because of me, all right? It's because it builds. It builds like, F equals MA still equals F equals MA. And in this class, A is equal to 0, all right? So you're like, wait, how could it be that hard, right? You're like, I did statics, right? Yeah, so all that still applies, right? But we're going to look at stresses. We're going to look at different configurations. We're going to then combine these different types of stresses with more complex loading. Okay? And by the end, we will all be confused together, okay? We really, it is. This class is tough, Okay, it is tough. That part is true. Okay, and I do hope though that it will be it won't be so painful. On the GroupMe, feel free to work together. Feel free to take a picture of your solution and post it. It's okay. It may not be right, okay, but it will help other people and you'll get likes and all that kind of stuff, right? I mean, I don't typically do that. I will probably be annoying typically because when someone posts and they ask a question, I'll be like, well, have you tried this? Did you try this? You got to remember this, right? And then one of you will just post the solution, and that's fine, okay? I'm not going to get upset, all right? We're not going to argue. Just be aware, though, that don't just copy the answers, right? You want to know the material so that when you go into the exam, you're ready to go, okay? There on the website, there are previous exams, and I agree with some assessment, okay? These exams from 2015 and 2016 are pretty brutal, okay? They're bad, all right? There's another thing I learned as a professor, all right? Initially, when you haven't taught a class before, you wanna at least this is my own pride. It's like, okay, I wanna show the students that I know what I'm doing. How do you do that? You make their lives miserable, okay? No, okay, that's not what we're trying to do, all right? I'm not gonna try to do that, all right? What we do like, though, to see is for those who have really absorbed the material, we like to give them an opportunity to really shine, okay? So the goal is to have a distribution in a large class like this. And you get students who are prove me wrong, okay? Prove me wrong. But it is, for the class's size, it will probably end up being a pretty normal distribution. If it's not, that's fine. We will go to 90 is an A, 80 is an B, 70 is a C, right? It's never happened though. Not yet. Okay? The curve helps everybody. Okay? But let's see. Maybe we can be that. Maybe we'll teach so well this semester that it'll be everyone will be stupendous. Yes.
Sorry, can you just repeat the normal distribution?
The normal distribution. All right. So the bell curve, right? So what will happen, okay? And this is a controversial subject, right? What will typically happen, right, is that we will have a distribution. Some people will be in the top 99%. Okay? And that's great. So they have an opportunity to show that they know what's going on there, right? And then a lot of other people will not be, okay? But we'll see that. And I think that you'll see that things end up being pretty fair. I mean, I think the spring semester, to get a D, all right, people talk about barely passing, all right? To get a D, I think you needed a 39%, okay? So let's try to raise that a little bit, okay? I don't remember what the C was, okay? But it was below 70, okay? It was below 70 for sure.
39, so we don't.
No, we're not going for that. We're going for good, all right? Okay. Let's do some technical work. Okay. So these questions are actually worth 0 points, okay? But we'll get an idea. What are two materials that shape your everyday life? Why do you think these materials break? And what would you like to learn? Okay, so this is completely voluntary. It's worth 0 points. It's on Canvas. Yes. Question? Nothing? Okay. Yeah, so go ahead and put them on Canvas and then we'll talk about it. Don't worry, we'll have time to talk about it. So go ahead. Oops. This is under Module 1, Session 1, Q1. Okay, so yes, we're getting wood, glass, steel, stainless steel, plastics, cotton. I like cotton. Did anyone grow up? Well, okay, I'm a little old. There was this advertisement the government, I guess, was putting out. It was like the touch, the feel of cotton, the fabric of our lives. No. Okay, no jingle. All right. Cotton is really neat. We make paper out of cotton, actually. We have in our lab. So you can pulp the cotton, and then you can use it as your material that you run through a hand sheet former. So essentially you pulp it. It's all wet, all pulpy, as you can imagine. You put it on a screen, you dry it out, and you get a sheet of paper. So cotton is fun. What else are people putting in here? Copper. Okay, copper and concrete. Copper is pretty expensive, isn't it? It's an amazing electrical conductor. Has anyone changed electrical outlets before? Yeah? What were you doing? Do you remember?
I just took out the socket and then just put the wires back in, but that's about it.
Yeah. Did you see lots of copper, right?
Oh yeah.
It's copper solid usually, right? And then going in. So yeah, I recently had to do some GFCIs, and I was glad I did, because a member of our family was using our corded lawnmower, and if you go over the cord, you will break it, and so the GFCI kicked right in, and no one got hurt. When I was a kid, I also I saw my mother take, you know how you have those baby-proof things for outlets, the plastic ones, and so sometimes if they're stuck, my mother would use a knife to get them out. So one time, my record player, right, I'm dating myself here, my record player, I couldn't get the plug out of the record player. So what I do, I went to the kitchen and I took a knife and I put it right in, and there were spikes.
What do you mean by plug? Like what?
The plug going into the outlet, right? The metal tines that are going in. Okay. So then I put it in right between the two, and there were sparks everywhere. And as a souvenir, she actually recently sent me the knife from when I was a kid, and it has these two like removed regions. Yeah, it was early in the morning. We didn't want to wake them up, but we woke them up after that. Let's see, what else have people put in? Okay, so rainbows. Okay, I like that. All right, and sunshine. Okay, so there's this professor. Actually, I guess he's retired now. I think Walter Lewin at MIT, and so he would do this lecture. It's got to be on YouTube. So I don't know if anyone watched Walter Lewin for Physics 1A. All right, but anyway, he's great. So he would do he's got a book. It's not Feynman's book is The Pleasure of Finding Things Out. What is this? Well, that's one of Feynman's books. I can't remember, and surely you're joking, Mr. Feynman, but I can't remember the name of this book. But anyway, he talks about rainbows. It's a composite, I guess, right? It's air and water.
Does energy count as
That's a good question. Is sunshine a material?
like is energy a material?
Yeah, I mean, not really. I mean, it's like a wave-particle duality thing, right? So we're not going to be evaluating the tensile strength of sunshine this semester. Yes?
What like officially defines material?
That's a good question. So off the top of my head, I would say, a collection of atoms that are adhered to each other in some way, okay? And it could be covalent bonds, it could be weak bonding, right? It could be different types of bonds, yeah. But it's something that we want to pull apart, and it's something for this class, actually we have a pretty good definition, because we're gonna say that it has some elasticity to it. Okay, so we can describe it in terms of how it displaces for a given amount of loading in terms of force or stress. So we're not going to be dealing with fluids, all right, which are viscous in nature. okay, and they don't have elasticity. A Newtonian fluid, a regular fluid, does not have elasticity. It has viscosity, okay, and so it responds to shear. But if you try to pull it apart, it's not going to pull back. All right. Now you say, well, but water really does, and yeah, you know, it has surface tension, right? But if you get away from the surface tension, if you're somehow able to remove the surface tension, which is very high, you're going to find that it's really a viscous liquid. Okay, great. All right, so those are some of. Thank you for humoring me with some of these. Let's take a look at. Okay, so how do I get back out of this? Okay. I want to see what people put down for why things break. And I'm sorry I didn't read all yours. They're good. I'll try to sample a slightly different portion of the class now. Okay. That's pretty good. Forces being applied to the materials cause them to break if the material is not durable enough at the area over which the force is applied. Okay, what is force over area? Yeah, so that's, you're both right, okay? Yes, force over area is pressure, right? And typically, so if you're in SI units, you might